Dear viewer, can we reach zero in absolute thermodynamic temperature scale? We will answer this question in this video. Absolute thermodynamic temperature scale was proposed by Kelvin, and it is defined as for a reversible cycle QH, that is heat supplied divided by QL, is equal to T suffix H, temperature of the source, divided by T suffix L, temperature of the sink. The scale is independent of property of any substance. It's an absolute thermodynamic temperature scale. But what is the magnitude of Kelvin? It is equal to 1 divided by 273.16 times the interval between triple point of water and absolute zero. Value of triple zero arbitrarily assigned, and the value of triple point of water is 273.16, and hence we infer 1 Kelvin is identical to 1 degree Celsius. All of us are familiar with temperature in Kelvin is equal to 273.16 plus temperature in degree Celsius. What it implies is the difference between the Kelvin scale and centigrade scale is equal to 273.16. If an engine operates between temperature limits T, that is the temperature at which the heat is supplied, and 273.16 Kelvin, that is a triple point of water, then we can write T divided by 273.16 is equal to Q divided by Q suffix L, where Q is the heat supplied at temperature T and QL is the heat rejected at the temperature 273.16. That is triple point of water. So this equation can be rearranged like this. So this is a absolute thermodynamic temperature scale. If you want to find the temperature T, we need to know the heat transfer quantities. Practically it is impossible, but still we can use it. It means practically it is impossible to measure, or it is practically impossible to operate an engine between Q and QL and identify the temperature. Now our aim is to find whether can we reach absolute zero in this scale. T will be equal to 0 when Q is equal to 0. But when Q is equal to 0, QL is also equal to 0, which gives an indeterminate form, which leads to a confusion or a choice. Therefore, to check whether we can reach absolute zero, Imagine number of engines are arranged in series like this. Engine A, B, C, D, and the source at T1 supplies heat to engine A. Heat rejected by engine A is taken by the next engine, that is engine B, and the heat rejected by the second engine is taken by the third engine, and so on. Therefore, when you go down the engines in series, the heat rejected gradually decreases. Also, the heat supplied. If you consider the net work done of all these engines, we need to add the work output by individual engines. Work output of engine A, B, C, D are given here. Therefore, the net work output will be the summation of all these things. We can cancel out. And finally, it gives the net work done is equal to Q1 minus Q pi, and Q1 is the heat supplied to the first engine, Q pi is the heat rejected by the last engine. Therefore, when we have number of engines in series, the net output, work output will be equal to difference between the heat supplied to the first engine and the heat rejected by the last engine. Now, if we increase the number of engines to n, we can reach a state where the heat rejected by the last engine, that is the nth engine, Qn equal to 0. By arranging n engines in series, the net work output is equal to Q1 minus Qn. Our aim is to reach 0 heat rejection. Therefore, Qn is equal to 0, which gives the net work output is equal to Q1. Net work output now is equal to Q1. So what is this Q1? Q1 is the heat supplied to the first engine. When net work output is equal to the heat supplied, the efficiency is equal to 100%. Obviously, it is impossible. It violates second law of thermodynamics. When Qn approaches 0, the temperature of heat rejection T suffix n also reaches or approaches 0. Tn is the temperature at which the heat is rejected. At absolute 0 temperature, that is when Tn equal to 0, Q suffix n is also approaching 0. Therefore, at absolute 0, isothermal Tn equal to 0, isothermal, and the adiabatic process. What is that adiabatic process? When Tn equal to 0, Qn is also equal to 0 or identical. So at absolute 0, isothermal and adiabatic are identical. Since connect n engines in series approaching Qn is equal to 0 gives 100% efficiency, which violates second law of thermodynamics, reaching absolute 0 in thermodynamic temperature scale is impossible. Thank you.